Welcome back, guys. This is Vishu from SavageCamp, and today we are going to talk about virtualization. So if you're new to this channel, I'm putting together a list of videos that will help you become a better infrastructure engineer. I have already covered the roles and responsibilities, the Linux, networking, and storage skills that you actually require for this role, and also the deployment types of infrastructure and the cloud types of any infrastructure. In this video, we are going to cover virtualization and the difference between VMs and containers. So we are at this moment of time where virtualization is something that you cannot ignore. Almost every infrastructure you're going to work at is going to have virtualization technologies, and it's better if you have a good understanding of these technologies before you go into any infrastructure related role. So let's get into the first type, which is understanding virtualization and virtual machines, and then we will cover what is the difference between VMs and containers. So let's understand what virtualization actually is. So suppose you have a server that has 32 GB RAM and 16 virtual CPUs, but that one server is going to take space of a single server. If you want to install 4 servers, you will have 4 different servers which would either have the same configuration, which would be 32 GB RAM and 16 virtual CPUs, or you can have 4 different servers with 4 virtual CPUs and 8 GB RAM. But what you're actually doing is you're filling up space. So for 4 servers, you need 4 physical space in the data center. And when you increase the number to suppose 16 servers, you're going to need 16 spaces in the data center for like 4 CPUs and 8 GB RAM. So as you increase the number of servers, you are also allocating more and more space, which we can avoid by using virtualization. Now, why do we want to use virtualization? Well, suppose you have 32 servers. If one of the server goes down, you have to actually replace it with a new one. And the whole procedure is long because you have to create a ticket with the vendor. You have to tell them what's wrong. They will ship out a new server. So you install the new server and you take out the bad one and you ship it back to the vendor. So all of this is going to take a week or two. So instead of doing that, what we do is we take the physical server and we divide it logically inside the server into 4 different servers. So 132 GB server and 16 CPUs would be divided into 4 CPUs and 8 GB servers. So one server can be divided into 4 different servers. So what you're actually doing is saving space, and you are also reducing the work that is needed because logically you have 4 servers, but it is actually sitting under one server. So that's the basic idea of virtualization. Now, how does this actually happen? So to understand how virtualization works, we need to understand hypervisors. So in the next section, let's go over what hypervisors are. So hypervisors are one of the main technologies that has technically changed the whole world. And the reason we have so many services running parallelly with such a nice efficiency is because of hypervisor. So what is hypervisor? Well, hypervisor is nothing but a technology that will help you logically create more servers inside a server, which basically means that you have one server, you can divide that one server into 4 or 8 different servers, which are called virtual machines. And as the name suggests, they are virtual. So they don't really exist in real world, but they exist inside this server. And how does these servers get their resources? Well, the hypervisor is the one which is allocating resources from the hardware to these virtual machines. And you are going to define what resources they should use. So if you want 2 virtual machines, you would allocate the hardware for 2 virtual machines. If you want 4, you would allocate the hardware evenly into 4 different machines. So you can also make like 16 machines of 2 GB RAM and 1 CPU. So what you're basically doing is dividing the hardware into different sections, and each of this section becomes a virtual machine. And instead of running one server, you're running 8 or 16 servers, and all of them are using the same hardware. So you're reducing the hardware cost, you're reducing the space, you're reducing the time management, because whenever a virtual machine goes down, you can delete it and create another one. So it's helpful when you are doing server administration or infrastructure designing, because you don't have to allocate spaces for 32 servers. You can just create one server and have 32 virtual machines running on it. So now that you know what hypervisors are, let's go into the type of hypervisors. So we covered what virtualization is and what are hypervisors. Hypervisors are the middleman that is going to allocate resources from the hardware to virtual machines and help the virtual machines run properly. So there are two types of hypervisors. There's type 1 and type 2. The type 1 hypervisor is the one that is directly connected to your hardware. So when you have a hardware, you install the hypervisor technology, which would be either Microsoft or VMware, and then that hypervisor is directly connected to the hardware, and every time you allocate resources, it's going to pull it from the hardware. So that's the type 1. The type 2 hypervisor is where there's an operating system sitting between the hypervisor and the hardware. So what it means is there's the hardware stack, which is your RAM and CPU and motherboard, and you install an operating system over this hardware. So it could be Microsoft, or it could be Linux, or it could be macOS. So this operating system is going to use the hardware. So all the resources are being allocated to the operating system, and over the operating system, you're going to install a hypervisor. So this is level 2 because there's 2 layers to the hypervisor. There's the hardware layer and there's the operating system layer. So whenever you are allocating any resources, the hypervisor now doesn't have access to the hardware. It has access to the operating system. So it is going to pull resources from the operating system and give it to the virtual machines. So these are the 2 types of hypervisors. And in the next section, we are going to cover containers and how they are different with virtual machines. So now that we have covered what is virtualization, hypervisors, type of hypervisors, there's one more important concept in virtualization, which is called containers. And basically everything you're using right now is working on containers. If you're watching Netflix, it's on containers. If you go on Amazon, they're running it on containers. If you use Google or Microsoft, it is running on containers. If you watch Disney or Hulu, basically every major technology, including cars technology like Mercedes, is also using containers. So why are people using containers, and what's wrong with just using virtual machines? Well, when you talk about virtual machines, you are going to install an operating system. And as everyone knows, operating systems are very heavy. They are going to take 20 to 30 GB of your disk space, and they are also going to take more resources. So the operating system will have to run its own user interface. It has to run its own programs, libraries, binaries. It's all going to take resources. And over that, you're going to run your application. So you have the base operating system, you have the hypervisor, then you have the guest operating system. So suppose 3 of them. So you have 3 guest operating system. Then this operating system is where you will run your application. So this application has one guest operating system, hypervisor, another operating system, and then the hardware. So there's like a lot of layers between this. And because there's a lot of layers, it's going to take a lot of time to boot up. Like every time you want to run this application, you have to turn on the guest operating system. So it will take some time to boot up, and then your application would start. But when it comes to containers, you have the guest operating system, and then you have the container engine. And over this container engine, you're going to run your applications. So you remove the guest operating system totally, and that's what saves most of the time and resources. So this application is directly talking to the container engine, and the container engine is going to allocate resources based on whatever you specify for this application. Now, the good thing about containers is like they don't take a lot of space. They will only use the bare minimum stuff that is needed to run the application. The disk space is very low. So the startup time is also very low because there's no operating system on which it has to run. So we don't need to start any operating system. It's more portable because that container engine would be a Docker file, and you can give that Docker file to anyone and they would be able to run it on their container engine as long as it supports Docker. And then it is also more efficient in this way because we don't have a big bulky operating system running that needs to be on every time we want to run the application. So containers are going to be a major part of any infrastructure, and we are going to cover this a lot in the future videos. Again, all of these are like brief summary, and what we are going to do is dive deeper into each one of this when it comes to Linux, networking, storage, virtualization, hypervisors. We are going to create a single video on each one of them where we will learn all of this in detail. So I think that's it for this video. This is supposed to be an introduction to all these concepts, and we are going to cover this in depth in the coming videos. So that's it for this video, guys, and I will see you guys in the next one.